So the learning outcomes, yeah. So the learning outcomes of this course, we have four learning outcomes, and you should reflect to these learning outcomes by the end of this semesters, and how, did I get these competencies? Yeah, you have to reflect these on by yourself by the end of the semester. So first is students can collaborate in a software development team using version control system or VCS. So the most popular one is Git, and the the platform provider, yeah, the most popular platform provider is GitHub. So I strongly recommend you to master Git version control system because that's compulsory tools. Yeah, that is a compulsory tool that you will be using in your future work. Yeah. Next is students can apply best practices on writing source code. So as a developers, you have to show your professionalism by writing good code. Yeah, code that can be understood by others, code that uh, can be maintained. Yeah, uh, and then code that can be extended and code that can be tested. Yeah. So that's the best practices on writing source code. So you have as a individual developer, as a professional, you should be able to possess these skills. Yeah, you should be able to possess this skill. And yeah, imagine maybe in the civil contract, in civil constructions, you hire civil workers that can do their job, that can do their job professionally. Maybe, yeah, that, yeah, they will piss you off. Yeah, you won't hire them because they don't have such competencies needed to build your house, for example. So those are same in software development. You won't hire software developers that don't have discipline and professionalism in writing good source code. So you have to train yourself. Third is a student can develop software using software design principles. So we have several design principles. Yeah, maybe in software design you already got some. For example, solid principles. The S stands for single responsibility principles. The O stands for open close principle. The L stands for Liskov substitution principle. The I stands for interface segregation principle, and the D stands for dependency inversion principle. So from those four principles, I will focus on just one, which is needed when actually all of five of them are needed, but I want to focus only one on its technicalities. I will discuss in depth. It's the last one is the D, the dependency inversion principles. Yeah, because the dependency inversion principles uh, will give you uh, will give you opportunity, yeah, to make loosely coupled software, which is uh, d- the good characteristic of good software is a loosely coupled software. Yeah, loosely coupled components. So if you have a software and the components constitute of that software is tightly coupled, then uh, it will it will give you problems in the future. Yeah, because tightly coupled software is difficult to maintain and difficult to extend. So I suggest you to make sure that you understand the dependency inversion principles, and the techniques is dependency injection techniques. Yeah. And last is you can write testable code. Yeah, because every code needs to be tested to make sure that you have mitigate the risk of introducing bugs. Yeah. If you don't test your code, you are introducing risk on your software program. Yeah. So, but actually, if you follow good design principles, at the end you will get uh testable software. Yeah. If you have any question, just raise your hand. Yeah. Okay. The prerequisites is software design. Have you took this course for maybe students from software engineering bachelor program? This one, perancangan perangkat lunak sudah dapat semua?
Yes,
Kapan? Last semester atau last year? Kapan?
last semester.
Last semester. Oke. So, materinya apa yang diajarkan?
If I remember correctly, it was design pattern, architecture a little bit,
Mm-mm.
um, trade-off like security and performance,
Oke.
something like that.
Oke. Design patterns means I think you studied like a gang of four design patterns, like creational patterns, behavior patterns.
Yes, that's correct.
Okay. Thank you. Yeah, so I think you already have a solid foundation for this class by taking the software design course. And next, the second is having a good understanding of object-oriented principles. So, like principles like encapsulation, polymorphism, yeah, and then what else? Inheritance, composition, yeah. You have to understand those principles because you will be using these principles again in the next in the other design patterns. Yeah, you will use this a lot, and then having a good understanding on one of these programming language. So actually, in this course, I will be using C Sharp or Go to deliver the course material. And git commands, yeah, knowing some of important git commands, so you have to I think you already familiar, yeah, you're already familiar with git commands, at least you have taken my object oriented class and I use git on that class, yeah, so I think you already familiar with git. This one is not class T. This one is class M. We have 48 students. 45 of them from 45. Yeah, 45 students are from software engineering bachelor program, and I think that we have three students from informatics, yeah, international undergraduate program. For those three, could you please raise your hand just to make sure that you follow the correct class? Because I have two class, class T and class M. Anak-anak IUP ada? Oke, Zaki, the other two, only one. Okay. Okay, so oh yeah, sorry. So I need to tell you that maybe for uh, in the next 4 or 5 weeks, yeah, we will be doing, I will be delivering the class uh, online by Zoom because I have some medical conditions so that I cannot attend on campus. But I hope I can attend as soon as I uh, got the permission from my doctors. Okay. So the room is EF 107, yeah. Okay. So next, I will explain. the lesson plan week by week, timetable. So 2 days is the first week. Yeah, the first week. The first week we talk about the lesson plan. Yeah, I will. Right now I'm explaining to you. I'm explaining to you the lesson plan and grading, this course plan and grading, and then next week in the second week, yeah, the in week two we have I will explain to you the project that I will be using throughout this class and how to collaborate using Git and Git workflow. Yeah, so maybe I will explain to you the case study, how to develop a team, and how the branching strategies in with respect to the team development, according to the team development, and pull request code review, and commit message convention. Yeah, we have, for example, in Git we have a semantic code mm, commit convention. Yeah, semantic commit convention. It's a guideline for you how to make a good commit message. And then we'll start the software construction in the third week. So introduction to software construction. I will explain to you what software construction actually is, the characteristics, yeah, what are activities included in this phase. I'll talk also about the technical debt, and then the differences between the construction phase, the architecture phase, and the design phase. Yeah. So you can differentiate these three phases. Yeah. And you know where to put your activity. Yeah. If you have certain activities, you know that this activity belongs to construction, this activity belongs to architecture, and this activity belongs to design phase. So you can differentiate them. And then in the fourth week, we talk about uh, something that is, I think, the source of problems in software. Yeah, where if you don't manage coupling, yeah, and dependencies properly, you will end up with a software that is hard to maintain, that is hard to extend. Yeah, so we'll talk about managing coupling and dependency injection techniques. Yeah, this is where we talk about the types of coupling. Yeah, there are several types of coupling, software coupling, uh, like afferent coupling, and then we have a dependency inversion principles, how to implement dependency inversion principles. Uh, Wait, sorry. uh, Types of coupling, yeah, and then dependency inversion principle, interface-based design. So you will know the concepts of how to manage coupling and how to implement dependency injection in your software. Yeah. Yeah, coupling is a problem, but without coupling, you cannot, yeah, you can make any system or software. Yeah, because a system consists of several components, and in order to get the expected result, the goal of the system, its components should interact with each other. Yeah. These interactions, this interaction of components make couplings between them. Yeah. The problem is if you have unmanaged coupling and you have strong coupling. So that's the problem of strong coupling. So you have to manage your software. You have to manage the coupling in your software so that they have a loosely coupled, yeah, interaction, loosely loose coupling. Yeah. So this all about it. We will talk this in week four. Yeah. Next, in week five, we have clean code in practice. So how to, like how to give a variable a name, a class name. Yeah, naming things is hard. Yeah, why? Why naming things is hard? Because naming things you need to understand. Yeah, you need to understand the context, the problems, the context or the problems that you are working with right now. You have to understand it so that you can give a proper naming to all of your components from the smallest part, which is the variable name, yeah, and then the method name, the class name, yeah, the package name, and then the component name. Yeah, you do naming all the time. Yeah, so you have to be wise when naming your components. And then how to properly write conditionals, how to properly write classes, properly write methods and commands. Yeah, commands is also important. If you use comments wisely in your source code. Yeah, actually, source code, you have to make your source code uh, self self-explanatory. Yeah, so the code speaks for itself without you have to explain more in the using comments. Yeah, you can use comments just to add something that cannot be understood from the code uh, explicitly. So you can add those in comments. Yeah. So you will learn this in week 5. Next is in week 6. Uh, so we'll talk about clean architecture, yeah, the domain-centric architecture. I think these are the trends right now that clean architecture makes your software loosely coupled, yeah, because we have defined each layer with its own responsibility, and we also manage the dependencies. Yeah, we have the dependency rules, and you will know the differences between the that database centric versus domain centric architecture. So what are the differences? You will learn this, and then we will talk about the layers inside the domain centric architecture one by one, starting from the innermost layer, which is the domain layer, and then we work all the way up one by one layer by one layer. We'll talk about application layer, and then we'll talk about the interface, delivery, or presentation layer, and how to connect to external dependencies using infrastructure layer. And then how is the calling mechanism, yeah, and how it is dependency rules, how its dependency managed. So this will be we will talk this in week 6 about specifically about clean architecture or domain-centric architecture. Next in week 7, so how to design a testable code. So testable design, wha- uh, what kind of design or what kind of code, yeah, written code that are testable. So we will discuss it here, and then how to test your code using AAA patterns, yeah, range, assert patterns, and how to do mocking, yeah. So because if you have dependency in in unit testing, you have to substitute your dependency with mock objects, yeah, with what do we call it? Like stun, yeah. You know, in movie we have a stuntman, which is the replacement of the real actor. Yeah, so it's a fake actor. So we'll do the same in software testing. We change the real component with the fake component. Yeah, using a technique called mocking. Okay, then in with eight we will uh, talk about the domain-driven design. So these are techniques that is useful to break down the complexities of software. Yeah, the essential complexity of software, which is uh, the domain problems that we are working on. For example, we are working on a financial system. So we have to understand the financial world, the financial terms, the financial languages. So by using DDD, we can use their tools. For example, from the strategic patterns, we have ubiquitous language, we have bounded context, yeah. And for the tactical patterns, we have entity, value object, aggregate, domain service, and repository patterns that we can use. So we can use them to model our business domain. Yeah. So we have business domain, the business logic, the domain logic, we can model them using these patterns. And then in the week 9, we will implement the business logic, yeah, the tactical DDD. We will implement the business logic in domain layer. Yeah, so you will be introduced to aggregate boundary. So what is aggregate boundary? Invariant, making sure that invariant is always true. Yeah. And then to make sure that you don't introduce like a domain logic bug, yeah, errors in your domain logic. And then how to encapsulate your domain in domain layer. And then you will know about the rich versus endemic domain model. So moving up to upper layer, we have application layer. Yeah. So in the application layer in week 10, we will talk about how to implement our application logic, yeah, which is the interaction of software components. So you will implement your use case, yeah. Maybe you already heard some the name of use case, yeah. The software design you represent your requirement in use case and you implement those use case in this application layer. Yeah, in domain layer you would implement your domain logic, but in application layer you would implement your use case. Yeah. And then you will learn the patterns. We have a CQRS, command query responsibility separation. The CQRS, it's useful to separate the comment that makes comments that make changes to your state, and then query, it's something that only get information. Yeah, you can only query information from your system, so you put that in query side, and for something that create changes, you put that in comment side. So we have to set here comment and query. And then you will have application service, yeah, how to implement interconnection to another system, yeah. For example, you have to call payment API from other vendor. You have to call email API from other vendor. You can define those interfaces in this application service. And then we talk about if you need to perform some transaction boundary to make sure that one, two, three, four operations are executed atomically, yeah, atomically, yeah, atom. So if you need to perform that in one transaction, yeah, atomically, then you can implement it in this application layer. And the next in week 11, we don't have class because it's national holiday. And then in week 12, we talk about infrastructure layer. This is where we implement all of the external dependencies. For example, if you call database, you will write your query in the repository layer and query in the query implementation. Yeah. So in infrastructure layer will be so your infrastructure layer will consist of repository, query, and then adapter, yeah. And then you will learn about how to create a DTO to make sure that the integration with external system doesn't force you to change your internal system. And in the week 13, we don't have any class. So no class because it's, I think, cuti bersama. Yeah, Idul Adha, national holiday. And last, in the week 14, we have API layer or presentation layer. So this where we implement all of the uh, implementation so that your logic can be accessed by another components. Yeah, you implement your REST handler, your API handler, you define your route structure, you define your modular folder structures, and you map the error from the lower layer. For example, the errors from domain layer will be propagated up to the application layer, and then from the application layer will be wrapped and then propagated to the upper layer to the API layer. And last, in the 15 and 16, we have evaluation assessment. We have a code review session, and in the last week 16, you'll have a written final examination. Yeah. Any questions regarding lesson plans? Maybe you have some questions that maybe something is not too clear. Just feel free to ask me any questions. Yeah. Okay, the assessment I will week by week I will give you GitHub classroom assignments. For example, uh, implementing dependency injection. I will give you GitHub assignments. Yeah, GitHub repository containing the starter code, and you have to do refactoring. Yeah, you have to refactor the existing code so that you have to refactor them to make them to implement the dependency injection, for example. And then for example, in modeling business logic, I will give you some business rules. I will give you some business rules like a requirement statement that contains business logic and business rules, and you have to implement using a domain model using DDD technical patterns. Yeah, you have to be able to understand the business rules and implement it using implement it by you only using the uh, business rules that I've given. Yeah, in the assignment. And then you will have personal project assignments, 25%. Yeah. So this assignment contributes 25% from your total score, your total grade. And for written examination, there are two, and then these examinations will contribute to 50% in total. Yeah, contribute to 50% of your total grade. So you have to make sure that you follow all of these assessments. Next is about the textbooks. Yeah, I recommend many textbooks here. Yeah, you can read these textbooks in in your spare time. For example, the main textbook for this course is Code Complete by Steve McConnell of Microsoft. So Steve McConnell is a Microsoft employee. So this book explains many aspects of software construction. Yeah, for example, writing clean code, managing complexities, yeah, managing dependencies, yeah, how to lay out the code. Yeah, so uh, he talks about those aspects of software construction in this book. And then Robert C. Martin specifically talk also about clean code. Yeah, clean coding, the clean name, clean naming, clean conditional, clean classes in this code, in this book, sorry. And he also has uh, another book about clean code, but in socio technical aspect, which is the clean coder. It's you as a professional, yeah. How you as a professional programmer should uh, embrace uh, clean code uh, techniques. Yeah. And then for dependency injection, I recommend you to read dependency injection book, principles, practices, and patterns book, yeah, by I forgot, Mark Simon. Yeah, this book is very very detailed about dependency injection. So I suggest you to read this book. Yeah, even though I already discussed dependency injection in this class, but if you read this book, you will get the complete understanding about dependency injection in detail. Yeah, in this book. So I strongly recommend you to read this book. And Clean Architecture, yeah, I recommend you to read Robert C. Martin. But for your information, the architecture that we will be using in this course, in this class, maybe we will have some different terminologies, yeah, different terms. For example, in clean architecture, Robert C. Martin used use case layer, but here we use application layer because I combine clean architecture, onion architecture, and hexagonal architecture. I combine these three architecture into one architecture, but I still call them as a clean architecture because the principles are same actually. Yeah. So we have clean architecture, hexagonal architecture, and onion architecture. These three are actually have same principles. Yeah. So maybe they have different terminologies in describing their components, in describing their layers, but actually they have same principle. Uh, and then for unit testing, I recommend you to read Unit Testing Principle, Patterns, and Practices by Vladimir Korikov. This is a very detailed book about unit testing, about the concept and also the practices. Yeah. And for the domain-driven design, yeah, uh, domain-driven design actually is uh, i- DDD was introduced back in 2003. Very, yeah, yeah. It's I think it's more than 20, yeah, 22 years ago. Yeah, 22 years ago. DDD was introduced by Eric Evans, and then by its famous Blue Book here. We call it Blue Book. And then Von Vernon try to augmenting it, yeah, make it clearer by implementing domain-driven design. This is clearer than this one. And then we have patterns, principles, practices of domain-driven design by Millet and Nick June. This is also very good in the detail of technicalities. So if you want to read or to master domain-driven design, I suggest you to read this book first. Actually, this one is the newest, Learning Domain-Driven Design, because it's easier to understand. Yeah, it's easier to understand by Vlad Kononov. Yeah, and this book is not as thick as the domain-driven design. Yeah, and implementing domain-driven design. I think the thickest one is this book, yeah, Patterns, Principle, and Practices of Domain-Driven Design. So I suggest you to read Learning DDD by Vlad Kononov. It's quite, not as thick as the Blue Book. And then moving to implementing domain-driven design and moving to pattern principles. And then after that, you can read the Blue Book. Why? Because this Blue Book is quite uh, conceptual. It's quite conceptual. Maybe for the first time, you'll have difficulties in understanding the DDD concept in this book, yeah, because it's very conceptual. So I recommend you to read from this book. Next is about these other aspects of software constructions is the socio-technical aspects, which is the teams, yeah, the people, the human that are building the software, yeah. So if you want to know, maybe in the future you have to lead a software development team, or you have a company that delivers software service, and you have maybe 30 to 60 to 100 or more developers, and you want to know how do I manage these people, all these people, how do they interact with each other? Nah, you can learn how to manage them by reading this book. This book is very practical in terms of how manage your team, how to divide your team, how to make them interact with each other. The title of the book is Team Topologies by Skelton and Pice. I recommend you to read this book, yeah, to so you can run your own team and you can run your own software company. Yeah. And then architecture for flow. Yeah. This actually uh, integrate the combine the team topologies and domain-driven design. Yeah. So you can read this. This one is, I think these three books are new book. And then lastly, we have domain-driven refactoring. Yeah. In this class, we only talk about Greenfield project. A Greenfield project is a project that is created from scratch. We start from zero. Yeah, zero code, and then we build the software, the code. We write the code one by one, line by line. But in many cases, join some, if you join a company that have existed, for example, 5 years, 10 years, or more than 10 years, uh, it is very possible that they already have some IT systems, they already have some applications, or already have existing software, and you cannot build your software from scratch, but you have to refactor existing software. You have to extend the existing software, yeah, and you have to modernize the existing software. For example, uh, in a company, they have a one legacy software, yeah, one legacy software which is monoliths, and then you need to transform, you need to modernize the software into modular system, or even uh, to the most sophisticated one, the microservices architecture. Then you can refer to this book on how to manage them, yeah, how to migrate, how to refactor them without stopping the services. Yeah, because you can stop legacy software, yeah, old software from working, from operational, just because you want to write a new one, and then you ask the other departments to stop working. Hey, wait, I will I will create a new software for you, but you please don't use this existing software. You just couldn't do that because they need the software. The software has its own business value, and sometimes the softwares the software is critical for the uh, operational of organization. So you can do that way. So you have to make sure that you can migrate the components one by one according to the business needs. So you can read this book. I recommend this book. Okay, so yeah, there are so many books, yeah. So as a software developer, as a software engineers, you have to learn. You have to always learn. You have to always read books. Yeah, books are good for your career, for your brain. Yeah, so you know, you are always learning something new, and you can implement it in your professional job. Okay, that's all about today's session regarding the lesson plan of software construction. You guys have any questions? If you maybe some some matters is not clear, please ask any questions. Nothing? Okay. So, okay, we have one here in the chat. Presence code. Oh, maybe you late. Okay, this one. For those who haven't record your attendance, please record your attendance here. Okay, for this week, I don't have any assignments for you, so you can try to search one of those books, and try to uh, read it. Uh, it will be good for you. And then next next week, I will talk about the project, yeah, and how to collaborate with Git. Okay, if there are no more questions, I think this is the end of today this week session. Thank you. I will end the meeting. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. See you next week.
Waalaikumsalam warahmatullahi
Thank you,
wabarakatuh.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
You're welcome. No problem.